you need to learn how to convert something like this into something like that. And what happens is that the first rule is for the epsilon, of course, but we don't have any epsilon here. So first check for epsilon. Second rule, okay, what's the second rule? Then look for unit production. Is there something on this side that is on this side? So if x goes to y and y goes to bc, you can just say x goes to bc and cb, and you can replace it with y. Why do you? And the reason for that is this is perfectly two digits. This is perfectly two digits, and we have to make the form of 2 capital digits or 1 small digit. Both of these are allowed. Now, after that, the second process, the second step. This is the y goes to and x goes to bc and cb instead of y. So we removed that rule. Then we have remaining rules left. For the remaining rules left, we make everything capital, and after making everything capital, we then distribute them into new variables and then put them into new variables, making sure that we only have 2 left. For example, we say s1 goes to a, s2, and then a, s2, and s2 will go to the remaining thing, x and b, x3 and b, and s4 and x and c. So it's pretty much common. For triple y, we can also do it that x was going to y, we can say x goes to 1y and goes to y1, and y1 goes to y. So in that way, we put 3 y's. So these are 2, and this is the third one. And that was the third one. And because in that way we knew that there were 3 y's, we added 2 y's in y1, and we added the remaining y here, and we added a y1. That way we gave all 3 y's. It was pretty much easy to distribute the y's. Then we had nothing left, except for the fact that whatever you make capital, is very important. Then comes the fourth step. Whatever you make capital, you write it. So I made a capital. A was a small a back then. Then I made it a capital A, you write it. So these are the steps that you follow, and then you basically end up something like this. Now we had similar question, and in this question we have everything solved. What happens is that this was the question itself. It says check epsilon. So what happens is that because it does have an epsilon in the s state, we see, okay, s goes to itself, and then we write it properly and then without s, then properly, then without s, then properly, without s. So with s and without s. Then we define rules like we say, okay, x1 goes to s and r1. R1 is the remaining bracket, s and the bracket. And then we can just define a new rule for this, L1. x2 goes to s and r2. S, and what's r2? R2 is this. And for this we can define a rule. Because these are treated as small variables, like small ones, and they can be single-handedly appearing, and these are considered as real capital ones. So these are considered like the brackets are considered as small alphabets. That way we have L1, which is this bracket, L1. We have x1, which is s and r1. So we have s and r1, so s and this bracket. We just converted it like this exact thing in this rules, and we wrote it. So L1 is the opening one, and we need the closing one like this to match this. R1, what is R1? This is the closing one. So L2, this is the opening one. X2 is s and the closing one. This is x2. See, s and r2, which is the closing one, and this. And this is how we have marked all of the rules, and we have just rewritten them. And now for the second language, we have also done that. We've written the language epsilon with, without, and then we just plugged it into variables by making them capital first. And when we made capital, we write rules for the capital. A was capital, a was small, we made it capital, so we write it. B was small, we made it capital, so we write it. And then that's the same thing for x1 and x2. We write them and we write the rules. For example, this was the B, x1 was here, S, B, C, so we write it. S was already capital, so we didn't make it capital, so we don't have to write a rule for it. But basically we have rules for everything else. Then this one we have already understood.